There are dozens of ways to analyze nanoparticles, but today let's keep it simple. Here are some basic characterization techniques that work for almost all nanostructures. Dynamic light scattering, DLS, used to find the average particle size in a suspension using scattering of light by the particles. Scanning electron microscopy, SEM, used to study surface structure and shape of dry or solid nanoparticle samples by scanning them with a focused electron beam to produce detailed surface images. Transmission electron microscopy, TEM, used to study internal structure and morphology of nanoparticles by transmitting a beam of electrons through an ultra-thin sample to produce high-resolution images. Zeta potential, used to measure the surface charge of nanoparticles in suspension, indicating stability by assessing the electrostatic repulsion between particles. X-ray diffraction, XRD, used to determine the crystalline structure, phase, and purity of materials by measuring the diffraction patterns of X-rays passing through the sample. Fourier transform infrared spectroscopy, FTIR, used to identify functional groups and chemical bonds in a sample by measuring the absorption of infrared light at different wavelengths. UV visible spectroscopy, used to assess optical properties and determine compound concentration by measuring absorbance in the ultraviolet and visible light range. Thermogravimetric analysis, TGA, used to assess thermal stability and composition by measuring weight changes of a sample as it is heated. These are your go-to tools for nanoparticle characterization. They're basic, but powerful, and they're the first step to quality research. Subscribe for breakdowns of each technique.